This is Algebra 1, Unit 6, Lesson 1 on simplifying expressions involving exponents. Now, there are many situations in science, engineering, and other fields where a process is governed by repeatedly multiplying or dividing the same quantity. Repeated multiplication and division is represented by exponents. So we have worked with these already, so let's review the basics in the first exercise. So each of the following problems involves basic exponent ideas. Answer each to review your previous knowledge. All right, represent 6 cubed as an extended product. Do not evaluate the product. What does 6 cubed actually mean? Well, the exponent means to multiply the 6 3 times. So this actually means 6 times 6 times 6, which is 216 if you want to work that out. But it just means to multiply 6 3 times. All right, if f of x equals 2x cubed plus 7, then f of negative 1 equals. All right, this is function notation. Remember, this is our x that we have to plug in. So f of negative 1 would equal 2 times negative 1 cubed plus 7. Now, by order of operations, what do we do first? We do the exponent first. And the exponent only applies to the negative 1. So this is negative 1 times negative 1 times negative 1, which equals negative 1. So this is going to be 2 times negative 1 plus 7. 2 times negative 1 is negative 2 plus 7 is equal to 5. So f of negative 1 is equal to 5. All right, let's see if we can do this one. If x to the third times x to the fifth is written in the form x to the n, what is the value of n? All right, now x to the third times x to the fifth, we are multiplying the same base. What do we do with the exponents? Well, we add them. All right, so remember, the reason we do that is x to the third is actually x times x times x. And then x to the fifth is x multiplied 5 times. 1, 2, 3, 4, 5, 6, 7, 8 times we multiply the x. So this is x to the 8th. Now, instead of having to write this out every single time, we can just say x to the third times x to the fifth is x to the 3 plus 5, which is equal to x to the 8th. This is what we're doing when we're doing this. Okay, so that is in the form x to the n will be equal to 8. All right, letter D. If the expression 5x cubed squared is written in the form ax to the b, what is the value of a plus b? All right, so in order to figure out what a and b are, we have to get this to look like this. So we have to deal with this exponent out here on the squared on the whole parentheses. So what does 5x cubed squared actually mean? It means 5x cubed times 5x cubed. All right, so we're multiplying these together. We multiply the numbers. 5 times 5 is 25. And then x cubed times x cubed, multiply the bases, add the exponents, is x to the 6th. Okay, so in this form, 25x to the 6th, what is the a value? Well, if I write ax to the b right underneath here, a would equal 25. And the b would equal the exponent, which is the 6. So what is a plus b? Would be 25 plus 6, which is 31. So there we go. Let's do some more exponents. If the length of a rectangle is 3 times 10 to the 5th meters, and its width is 2 times 10 to the 4th meters, what is its area written in scientific notation? Okay, area, remember, for a rectangle is length times width. Length times width. Okay, so this is written in scientific notation. The length is 3 times 10 to the 5th, and the width is 2 times 10 to the 4th. All right, now this is all multiplication, so I can multiply these in any order that I want. What if I multiplied and regrouped these? What if I did the numbers and then the powers of 10 in another group? So if I did 3 times 2 in one group, times 10 to the 5th times 10 to the 4th. 3 times 2 is 6. 10 to the 5th times 10 to the 4th. Keep the base, add the exponents. 6 times 10 to the 9th square meters. So you can, when you multiply, remember by the commutative property, you can rearrange in any order to multiply. So I just multiplied the whole numbers together, and then I multiplied the powers of 10 together, and then added their exponents. All right, letter F. Rewrite the product 3x squared squared times 2x to the fifth cubed as an equivalent expression in simplest exponential form. Basically, we want to get this down to one coefficient, one base, and one exponent. So, what does 3x squared squared mean? It actually means 3x squared times 3x squared. What does 2x to the fifth cubed mean? It means 2x to the fifth times 2x to the fifth times 2x to the fifth. Okay, let's multiply these together. We have the numbers. We have 3 times 3 times 2 times 2 times 2. Those are all the numbers. And then I have the exponents. X squared times x squared times x to the fifth times x to the fifth times x to the fifth. You actually don't have to rearrange these down. You can just multiply them as they are, but I'm just showing you where the numbers come from. All right, so 3 times 3 is 9, 2 times 2 times 2 is 8, 9 times 8 is 72. And then x, and then I have 2 and 2 is 4, and 5 is 9, and 5 is 14, and 5 is 19. So this is 72x to the 19th, written in simplest exponential form. I have one coefficient, one base, one exponent. All right, so that's a quick review of the rules for exponents. When you multiply the same base, you add the exponents. Writing an exponent means you multiply the base however many times the exponent says. All right, let's do some simpler equivalent expressions. All right, now we would also like to be able to write simpler equivalent expressions involving ratios or division problems involving exponents. This all comes down to your ability to unmultiply fractions, and the next exercise will illustrate. Now, this is a little different way of doing it. I'm going to show you this way, and I'm going to show you the way that I would do it. Consider the expression 2x to the 6 over 4x squared. Okay, write this expression as the product of two fractions, one of which is equal to 1. Basically, what they're asking you to do is to find a GCF between the numerator and the denominator. All right, so what number goes into both the numerator and the denominator? It would be 2. Okay. What number goes into, what is the biggest exponent I can take out of x to the 6 and x squared? It would be x squared. All right, does that equal 1? Yeah, it does. All right, now, 2x to the 6, if this is 2x squared, what was multiplied by it to get 2x to the 6? It would be x to the 4th. And then 4x squared, what was multiplied by 2x squared to get 4x squared? It would be 2. So, when you simplify this, 2x squared over 2x squared is 1 times x to the 4th over 2, which is just x to the 4th over 2. All right, so taking out the 1 right here is basically taking out the GCF. I like to do the division problems as a little bit different simplification. I like to simplify the coefficients and then simplify the exponents using division rule. All right, so I'm going to rewrite this as separate fractions. I'm putting the coefficients over each other, and then x to the 6 over x squared. 2 over 4 reduces to 1 over 2. X to the 6 divided by x squared. What happens when you divide the same base? What happens to the exponent? Well, when you multiply, you add, so when you divide, you subtract. So we have 6 minus 2 is x to the 4th. And you put the exponent to keep it positive wherever it's bigger. So x to the 4th is going to go here over 1. Multiply these together. 1 times x to the 4th is x to the 4th. 2 times 1 is 2. Did I get the same answer? Yep. All we're doing here is we're taking out a GCF and simplifying it. This one, I'm just writing them as separate fractions, simplifying. Either way will work. Okay. Now, we're going to rewrite each expression as, for simpler terms, but we're not going to rewrite it equal to 1. What we're going to do is we're going to do it by division. All right, so 5 to the 7th divided by 5 to the 3rd. All right, even though the base is a number, we keep the base and we subtract the exponents. So that would be 5 to the 7 minus 3, which is 5 to the 4th. And that is your answer. All right, now if you're doing it by the ones, what goes into both of these terms would be 5 to the 3rd. 5 to the 3rd times 5 to the 4th is 5 to the 7th. 5 to the 3rd times 1 is 5 to the 3rd. So this divides out to be 1. 5 to the 4th over 1 is just 5 to the 4th. All right, I like the division rule better. Okay, but where you have to be careful, the division rule is where your exponent is bigger. We have x to the 4th divided by x to the 10th. Well, we want to subtract the exponent, but where is the exponent bigger? It's bigger on the bottom. So if I take x to the 10 minus 4, the 10 is on the bottom, the exponent's going to have the bottom, this is going to be x to the 6th. But what's on the top? Well, it would be 1. Because technically what you're doing is this. X times x times x times x, and then 10x is on the bottom. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, if I divide these out, cancel each other out, I'm left with a 1 on the top and 1, 2, 3, 4, 5, 6 on the bottom. That's what we're actually doing. So to keep your exponent positive, put it where it's bigger. All right, when we have more combinations of exponents, just split them up and put them over each other. X to the 4th over x times y to the 8th over y to the 10th. All right, x to the 4th over x. Now what exponent is on the x down here? Remember, it's x to the 1. So when I divide, I'm going to subtract the exponents. Where is the exponent going to end up? Well, it's bigger on the top, so x to the 3rd will be on the top. I'm going to put this over 1 just to line it up. All right, y to the 8th over y to the 10th. When you divide, what do you do with the exponents? You subtract them. All right, where is the exponent bigger? It is bigger on the bottom. So 8 and 10 here, the subtraction is going to be y squared down here, and there's going to be a 1 here on the top. Multiply across. X third times 1 is x to the 3rd. 1 times y squared is y squared. So there we go. Okay, so when you divide, you subtract the exponents, put them where it's bigger to keep the exponents positive. All right, let's try some more complicated ones. Let's combine a couple of rules. Rewrite each of the following as equivalent exponential expressions in simplified exponential form. Basically, get it down to a single number, base, and exponent. So 3x squared cubed over 9x to the 4th. Well, first of all, we have to deal with the cubed. Remember, that actually means 3x squared times 3x squared times 3x squared over 9x to the 4th. All right, so we want to multiply these together. 3 times 3 is 9, times 3 is 27. X squared times x squared times x squared, add the exponents, is x to the 6th over 9x to the 4th. Okay, now we need to simplify this. So what I'm going to do is I'm going to split them up into separate fractions with the coefficients and then the x's, because they're all multiplied together. All right, so I have 27 divided by 9 is 3, technically 3 over 1. And then x to the 6 divided by x to the 4th. When you subtract or multiply, divide the same base, you subtract the exponents and put the exponent where it's bigger. 6 minus 4 is 2, and it's bigger on the top, so x squared would go on the top. So multiplying together, 3 times x squared is 3x squared over 1, which is actually 3x squared. And there's your answer. Okay, let's try letter B. 5x squared y cubed squared over 10xy squared. Well, 5x squared y cubed squared means 5x squared y cubed times 5x squared y cubed over 10xy squared is 10xy times 10xy. Okay, so let's multiply these together. 5 times 5 is 25. X squared times x squared is x to the 4th. Y cubed times y cubed is y to the 6th. In the denominator, 10 times 10 is 100. X times x is x squared. Y times y is y squared. All right, now let's split them up into separate fractions. 25 over 100. X to the 4th over x squared. Y to the 6th over y squared. All right, 25 over 100 reduces as a fraction. That's 1/4. X to the 4th over x squared. Subtract the exponents, put it where it's bigger, would be x squared on the top. And then y to the 6th divided by y squared would be y to the 4th on the top, 1 on the bottom. Multiply the top together, you get x squared y to the 4th over 4, and it's simplified. All right, so let's look at the simplification of 2x quantity squared over 4x cubed. Let's give the reason. 2x squared over 4x quantity cubed, why is it 2x times 2x, 4x, 4x, 4x? That's the definition of exponents. Okay, and then why could we regroup them like this? That is the associative property. And then this last one is just multiplying fractions.